Good day, welcome to this tutorial and I'm going to teach you how to create an inventory system like the Diablo and Path of Exile's inventory system where you can manage based on the width and height of the item. These are oftenly used in RPGs, but you can use this also for survival games where you can manage how much the character will carry. Okay, so let's get started. For this particular project, you can browse itch.io and look for game assets that you want. You can create your own, but of course you can also try and download assets that were made by other creators. For other sites, you can also go to opengameart.org and you can browse different game assets. You can try 2D game art and different sprite sheets. For example, this asset, which is appropriate for our inventory. Just make sure to follow their indicated license. As for me, I will use RPG weapons made by Quintino Pixels from itch.io, which are appropriate also for our inventory. You can also follow them if you want to be updated in their different creations. Here's the file that I have downloaded and I open it in a sprite. This is a sprite sheet, but we have to make sure that each item or the items that we want must be in its own particular image file. So let me just check the grid settings to help me in snapping a particular sprite or particular item. So I will put this on the top and snap it in the middle of the 16 by 16 grids. So each of these squares, for example, this square is 16 by 16, and then this is 16 by 32, 16 by 48, and 16 by 64. Overall, this sword image or this sword item will be 32 by 64. Let's add a new layer that will act as the background of the item. You can also add this outline, for example, this green line, so that you can see the boundaries of that item. Then we have to crop the image. So select that and press crop. Then now we can export the particular image. So here's also an example for this particular shield that I will export. After those exporting that we did earlier, this will be the resulting images. I have 8 different items for my inventory. Then I can verify if the dimension is correct. Okay, it must be in the multiples of 32. Then in your Godot project, let's create a new folder. Let's call that item sprites. Then let's open that in the file manager. Also, open the images that we have exported and then copy those images into the created folder. Select all those images, click import, and then uncheck the filter and put check in the anisotropic and then re-import. So why do we have to do that? By default, Godot filters all images that is imported and it will result in a blurry images. So to fix that, we did anisotropic and remove the filter. Let's create a new user interface node. Then let's call that main root. Let's add another child node. Let's select a new color rect. And let's call that CR inventory panel. Let's select the newly created color rect. Click the color. And then let's choose a darker color. So I think this will suffice. Let's add another child node. Then select sprite. Okay, and then let's call that sp underscore inventory grids. Next, I also have this inventory grid, which you can also get in the project's repository. Let's validate that if this image is 32 by 32. Okay. So let's find the grid. Okay. Then let's move that in the root folder of the res or the resources. Okay. Let's make this grid image unfiltered and anisotropic. Re-import. And don't forget to make this image repeatable. Re-import. Click the sprite. Drag the grid. And then in the offset, uncheck the centered. And then enable the region. Let's say 256 by 256. So it will be 8 by 8. Then click the panel. In the rect, also 256 and 256 in the size. Let's add another child node in the sprite of inventory grid. And then select the area 2D. Let's call it A2 underscore inventory. Let's add another child node, collision shape 2D. And in the shape, let's select rectangle shape 2D. Let's check the grid settings. Okay. And then use a smart snap and use grid snap. Move the collision shape. Okay. And put it in the middle. Then extend its bounds until it covers all the inventory grids. Okay. Then let's create our item prefab using the control node. Let's see our items. Okay, the bow. Then add another child node, sprite. Then let's call it our control node as bow. Okay. Then in our sprite, let's drag the texture of the bow. Okay. Then uncheck the centered. And then let's add another child node, area 2D, and collision shape 2D. Okay. In the collision shape, let's select another rectangle shape 2D. Then in our settings, okay, so grid step 16 by 16 for our easier snapping. Okay, so move the collision shape, the middle, then extend the bounds until it covers all the item. Let's save the scene. Let's create a folder, Prefabs, and then bow. Okay, so that's good. Another thing, let's configure again the grid snaps. Okay, so 1 pixel by 1 pixel, and then move the bounds 1 pixel less in all sides. The purpose of this is to not let the collision shape touch another collision shape of other items. Okay, and then resave it. And then let's create another prefab for the other items. I'll fast forward in this time until I finish all the items. Another thing, let's open our bow, and then let's add those nodes in a group. Okay, let's call it item. Then also do that in all the prefabs. One last thing with regards to our item prefabs, we must make sure that the control node's size matches the sprite size. I will also do that for the other items. After doing that, let's go back to the main scene. Then highlight all the items and drag it in the main route. Okay, now we can see that the item prefabs are now added in the main scene. Okay, so let's just move it. The visual preparations are now set, so let's add a script in our main route. Okay, not that. Let's call it inventory management. Okay, so delete all this. Let's add a constant for our tile size. Let's also add our inventory dimensions. 8 by 8 because 256 divided by 32. Add these three variables that will hold our nodes. Let's create our ready function. Let's refer to the CR inventory panel node in the tree. Then let's create the reference for the inventory grids. And the reference for our area 2D. Remember that we have put the item prefabs in a group, so let's add signal connections for those different item prefabs. Create a function, add signal connections, and then the control item. Control item dot connect. Let's put GUI input in the signal, self in the target, and cursor in the item, or cursor in item. Okay, so our method is cursor in item. And then control item. So let's pass the control item. Then let's check our signal for our control. So GUI input. So GUI input also requires an input event parameter. So let's put in our cursor in item the input event. Then in our cursor in item function, then our control item. Okay, so we put event colon input event. For the meantime, let's put pass in there. Okay. Let's add another connection for our signal, control item, that get node, sprite slash area 2D dot connect. For the signal, let's use the area entered. Then, for its parameter, it also needs an area parameter. So for our connection, let's put area entered, comma self, comma overlapping underscore with underscore other underscore item. Then let's also pass the control item. Then duplicate that, and we will do that for our area exited also. Okay, so area exited and not underscore overlapping. Let's create the function overlapping underscore with underscore other item. Okay, so area. So we must put also the parameter area. And then our control item. Again, let's put pass for the meantime. Then duplicate that for our not overlapping. Okay, so for our cursor in item, let us create a new input. Okay, so input map and then select underscore item. Let's add a mouse button and then left mouse button. Okay. Then let's put event that is action press. Select item. Then let's create a variable. BL underscore is item selected. Okay, so it will be our checker or our tracker if the item is selected. Okay, so it must be boolean. And then default it to false. Then let's create another variable. Control underscore selected item. So this variable will hold the currently selected item. Okay, so let's use that two variables. Okay, so BL underscore item selected equals true. And then control underscore selected item equals control underscore item. Let's add another variable. Var v2 underscore item previous position. Okay, so let's make that vector 2. Then let's save our control selected item, the track position, for our previous position. Okay. This variable will be used if the item position is invalid. Okay, so it will return to the previous position. We get our position from our rec section and then the position. Add another if condition. If event is input event mouse motion. So it will be used if our item is drag. Then let's check if an item is currently selected. So BL underscore is item selected. Let's create another variable. BL underscore is dragging item. So let's make that boolean and then default to false. Let's assign true if the item is dragged. Okay. If event, okay, so let's add another one. If event that is action, release, select item. Put BL underscore is item selected equals false. And then BL underscore is dragging item equals false. And control underscore selected item equals null. Let's now create our process function. If BL underscore is dragging item, and then control underscore selected item dot rec underscore position equals self dot get global mouse position. Let's check our work. Okay, so save that and then okay, so let's try to move the item. Okay, so it's good. It's following the cursor. So we can now drag and then release. Okay, so this is good. Then also, as you can see, as we are dragging the item, other items are overlapping that selected item. Okay, so to fix that, let's create another variable, I underscore selected item z index. The higher the z index, then the item will be displayed in front in comparison with the other items. Let's assign the z index whenever we are selecting an item. Okay, so the z index is located in the sprite node. Set z index and then the selected item z index. So as you can see here in our sprite, so the sprite has z index, so the default is 0, and then in our sprite in the help, so the function for that is, let's see, z index, so it's located in the node 2D, and then z index. Okay, then after we release the item, let's put the z index in the default. Okay, so it will default to 0 again. Then let's try that. Okay, so as we drag down the item, it will be in front of the other items. Okay, and then after we release that, the item will default to 0 z index. Then in our overlapping function, okay, so if area that get parent equals control underscore selected item. Okay, and then let's return. And then get parent is because that area 2D, its parent is the sprite and then its parent is the bow. Let's create another one. If area equals a2 underscore inventory. So return again. Then let's create another variable, an array for the overlapping items. Okay, so r underscore overlapping with items. Then r underscore overlapping with items dot append, and then let's put the control item. Let's copy this. Okay, and then let's put that also in our not overlapping. Okay, and then let's change the append to erase. Let's print that. Okay, so print and then our array. And then now we can see that as we are overlapping with the other items, the array is populated. Now let's enhance our overlapping display. Okay, so open the bow, prefab, and then in our sprite, you can also use materials to indicate that the item is in invalid position, but as for me, I will use the modulate. Okay, so as we change the modulate color, the item's color is also changed. Let's put if our selected item and then in our selected item dot get node and then get the sprite that modulate equals. Okay, so for the color, so the format will be color and then RGBA. Okay, let's create another variable, call underscore invalid color. For the R value, let's put 1 and then 0.36 and then 0.36 and then 1 for the A. So how did I get the colors? Okay, so these values are in 255 format. So how did I get those numbers? So I divided each number. Okay, so for the R, 240 divided by 255. And then that's the number I put in the color. So do that for all the values, G, B, and A also. Let's duplicate that. Okay, so let's create a valid color. So the valid color will be used if the item is in the right position. Okay, so it will just default to the value of 1. Then in our modulate, put the invalid color if the item is overlapping. Duplicate that, and then for in our not overlapping, let's put the valid color. Then if we try that, okay, so as we overlap with the other items, our selected item will be in red. Again, as we try that, we will encounter this bug. Okay, so the overlapping item is not updating if it is overlapping with the other items. Okay, so we are missing a condition. So let's put, okay, so instead of the control selected item, so let's put the array and then checks for its size, and then if it is equals to 0 and the boolean is item selected, so if it is true, now upon checking again, as we overlap and not overlap with the other items, the item is now correctly displaying our correct color. And then for our ready function, let's put the signal of the A2 inventory. Okay, area entered and then area exited. Let's create those two functions. Item underscore inside underscore inventory, and then function item underscore goes underscore outside underscore inventory. Let's create another variable. Okay, so var bl underscore is selected item inside inventory. And then default it to false also. Then in our inside function, let's assign true in that variable, and in the outside function, let's assign false. Then let's fold that. Okay. And then let's check our cursor in item. If array overlapping with items that size is greater than 0, then in our control selected item, rec underscore position. Okay, so let's demo this. Comment this first. And then as we overlap our item and then release it, the item is not returned to its original position or its previous position. So uncomment that again. And then put the previous position that is assigned when we selected the item. Okay. And then let's revert the modulate color to the valid color or the default color. Else, okay, so add else. If bl underscore is selected item inside inventory, create an if inside the if. Okay, so if not add item or add underscore item underscore to inventory, and then let's pass the control selected item. And then let's put the pass, okay, for the meantime. And then I will explain later the purpose of this function. So let's create that first. So add underscore item underscore to underscore inventory, and then the parameter control selected item. So let's call that instead control underscore item. It will be our local variable. Let's put pass for the meantime. Then let's remove that pass. Okay, and then put var v2 underscore slot ID. So it will be vector 2 and be assigned by control item dot rec underscore position. Then let's divide that by let's see, for our tile size. Okay, so v2 underscore tile size. And then duplicate this. Let's change the name to v2 underscore item slot size. For the value, let's put rec underscore size. So for the item slot size, so for example, this dagger, it will take a 1 slot. Okay, because it is 32 by 32. And then for our buckler, so it is 64 by 64, so it will take 4 slot. Okay. Okay, so this item slot size, so rec size. So let's check this dagger. And then our rec size is 32 by 32. And then for our buckler, 64 by 64 again. Okay. And then divided by the tile size. Okay. So by that, we can get the correct number of slot the item will take. Let's create another variable, v2 underscore item max slot ID. So it is a vector 2. And then let's assign v2 underscore slot ID. Then plus v2 underscore item slot size. Then for this sum, so let's minus vector 2 1 by 1. Okay, so because the slot ID starts with 0. Okay. Another thing, so let's go to our process function. Okay. And then in this position or in this part. Okay, so let's try to run that. Okay, so as you can see, my cursor is in the upper left of the item. Okay. And then to enhance that item positioning in the cursor, let's create another variable, var v2 underscore cursor item drag offset. Okay, so it is a vector 2, and then let's assign vector 2 and then negative 8 by negative 8. Copy that, and then let's go to the process function, and then let's add that vector to our get global mouse position. Then if we try to run it again, the item's position takes the offset into consideration. So to improve it further, let us put a snap in the resulting vector. The snap value will be the tile size. Let's try to run it again. Then, as we drag the item, it is snapping to the tile size. Okay, so 32 by 32. Let's add another variable. Let's call that v2 underscore item max slot ID. So this will be a vector 2. Assign v2 underscore slot ID plus v2 underscore item slot size. Then minus vector 2 1 by 1 because our slot ID starts from 0. We must also make sure that if our item is in valid position, like this bow, so half of the bow is outside the inventory. let's create another variable, v2 underscore inventory slot bounds. Then let's use our v2 underscore inventory dimensions. Then also minus a vector 2 1 by 1. Then let's add a condition. If v2 item max slot id that x is greater than the v2 inventory slot bounds that x, then we will return. Let's duplicate that, then let's change the x to y. Let's put return false. Okay. And then return false also for the y. Okay, so if the item is not out of bounds, let's return true. So basically, the purpose of this function is to make sure that we add an item to the inventory and then check if the item is inside the inventory. Okay, so if it is a false, so let's put back the item to its previous position. Then if we try it, let's put the item in the wrong position. So you can see that the item is returning to its previous position. Now let's add the code that will put our items or our record of items to a dictionary. Okay, so var dct underscore inventory items. Duplicate that and then let's create for the slot. Okay, so inventory item slots. So for our structure for the inventory items, so each key will be our item itself or the control node. Okay, so each item will have a value of the position in terms of our slot ID. Then let's duplicate and then let's say item A. Okay, and then item B, item C. All those items will have a different slot ID. Next is the inventory item slots. Okay, so the structure for that will be the slot ID, and then each slot ID will have the reference of the control node or the prefab itself. For this example, slot ID 0 by 0 is occupied by item A. Then let's create another one. So for slot ID 01, it will be occupied by item B. An item can also occupy different slot ID depending on the size of the item. So for this example, item C occupies slot ID 02 and slot ID 03. Let's add a condition in our add item to inventory. If DCT inventory items already has the item, then let's remove that item. For the parameter, let's put the control item. Let's create that function. Then back to our add item to inventory function. let's create a for loop. Y underscore counter. In range of v2 underscore item slot size dot y. Then another for loop, x counter in range v2 underscore item slot dot x. Inside that nested for loop, let's add dct underscore inventory item slots. Inside the vector 2, let's put v2 underscore slot idx or slot id.x plus x counter. Duplicate this, and then let's do that also for the y. Then let's assign our control item. After we assign the item to the particular slot, we must also assign that slot to our particular item. Okay, so we use the control item in the key, and then v2 underscore slot id. The slot id that is indicated here is the upper left side of the item. So that's where our cursor is. Then let's go back to our remove item in inventory function, but let's just rename it. Okay, so let's put underscore slot. For our parameter, let's add another one. Okay, so let's copy this. Then, okay, so remove the hash. So this parameter or this variable will pass the position of this particular item. Okay, so let's also add the control item again. Okay, so let's call that pass parameter by v2 underscore existing slot id. Then let's copy the v2 item slot size in our add item to inventory. Then paste it in our remove item. Then let's also copy our for loop. Then paste it in our remove item. And then instead of slot id, let's replace it by existing slot id. Then if it has the particular position, so we will remove that particular key in our inventory item slot dictionary. In our scene tree, let's add a child node. Okay, so that node will be button. Let's call that button btn underscore sort inventory. Let's add a text for our button sort inventory. Back to our script, let's add a reference for our button. Then let's locate our button, then connect, then let's use our button up, self, and then initiate sort inventory. Let's create that function. Then if our inventory items is empty, we will just return. For our sorting algorithm, we will go from top to bottom, filling that entire columns. Okay, if possible. Okay, and then we will go to right. So from left to right, after filling those top to bottom inventory slots. Meaning, we will fill this, okay, first this, and then next. Okay, so we'll fill these particular slots, and then going from the left to the right. Next, we also need to know the height and width of the item. And we will prioritize the height over the width. Okay, so this is the height. Then, the width of the item. Then, before we sort the items, let's remove their connections or their signal connections. Let's create a for loop. We need to remove the connections because it will cause problems if we are sorting and then our items have collisions. Next, let's create a variable, an array for our inventory items. So this will be a local copy of the inventory items. To populate our array, so we must convert our dictionary to an array. Our array will also consist of the item slot size. And then let's insert the item and the item slot size in our inventory items array. Then let's go to the documentation of array. Let's find a sorting function. Okay, then so we can see there are two sorting functions. One is the default that sorts strings, and then another one that is custom or depending on the functionality that you want. Let's try the latter. So like our explanation earlier, so our first priority is the height. Okay, let's create that custom function. If the y of both items or the adjacent items in the array is the same and their x is greater, we will return true. But another condition, if the y is greater, we will disregard the x and we will return true. Let's create another if condition, sort inventory, and then our parameter. Let's put pass for the meantime. Let's create that function, sort underscore inventory. Let's put our array in the parameter. Then let's clear the existing inventory item slots. Let's create another variable, inventory blank slots. Okay, so this array will hold all 64 inventory slots. Next, we will populate our blank slots array with vector 2. Then let's create these three variables, previous item, item counter, and then is slot available. Then we will loop through all the items and we will check if a particular slot is available for our items. Let's create another array. Let's call this assign slots. Then let's create a for loop. So for each blank slot, we will put is slot available true by default. Then another variable for our upper left slot ID. Then we will generate the item height and width of the ID. So basically, this generation of the item height and width will be the slot IDs. In the first entry in the loop, we will put the blank slot in the upper left slot ID. Then we will create another for loop. So this part will be the checking of our item if it is inside the inventory and then if the particular slot is available for that particular item. So if the slot is not available for that particular item, we will make our slot available variable to be false and then we will clear the assigned slot and then we will break the for loop. So if the slot is available for the item, we will assign that item to that particular slot and we will remove from the available slots the assigned slots. Then we will clear the assigned slot. So for the next item, we can now check again for the possible slot or the possible available slot. Let's also increment the item counter. And then last, if all the items are sorted, we will return true, but if not, we will return false. Then let's go back to our initiate sort inventory. If the sort inventory returns false, then we will sort again. So by this time, instead of the height, we will prioritize the width of the item. Then we will create the with prioritize sorter. Then if same y and greater x, then we will return true. And if greater x, we will disregard the y. So let's call the sort inventory again. After sorting the inventory successfully, we will then again add the signal connections for all the items. So let's now see our end result. If you find this video helpful, you can like and subscribe for more videos and more tutorials in the future. Thank you.